Hey, guys. Today we're going to start our unit on organic chemistry, so get excited for that. Here's what it is. So, what we're going to be doing is we're just going to be talking about the very, very basics of what organic chemistry is and naming some things. Everything in our class about organic chemistry really focuses on the carbon. So, you normally, if this was a normal year, I'd ask you to draw the structures. I'm just going to do that for you right here. And what I want you guys to take a look at is in each of these correctly drawn Lewis dot structures, how many bonds are there coming off of carbon? That's the question. Hopefully, you've taken a look at it and you can see that each one of these carbons that are now highlighted in yellow here have four bonds coming off of them. That's not a coincidence. Carbon, it turns out, will always form four bonds. Will just about always form four bonds. However, in organic chemistry, we'll be dealing with specific molecules where carbon will always have four bonds coming off of it. Now, I want to introduce you to the main type of structure we're going to be working with this unit. It's called a hydrocarbon. Now, as the name suggests, hydrocarbon, it's got two atoms in it. One of them is carbon, and the other one is hydrogen, right? So it contains hydrogen and carbon. Here's one example of a hydrocarbon. This is the simplest hydrocarbon. This is CH4. We call it methane, and we'll talk about why it's called methane in the next segment of notes. But for now, CH4, known as methane. Here are a bunch of other carbon chains, just a combination of carbon and hydrogen. This one has five carbons, this one's got six, and this one's got seven. These would be pentane, hexane, and heptane, just in case you were curious. So yeah, a hydrocarbon is just a long chain of carbons and then hydrogen sticking out of it. Notice here how no matter how many carbons I have, whether it's one, five, six, or seven, they've all got four bonds coming off of them. Um, so here's a couple facts to know. Carbon to hydrogens are always single bonds. And then with carbon to carbon, we could either have single, double, or triple. These form three different types of hydrocarbons. If every bond is a single bond carbon to carbon, we call those alkanes. If it's a double bond, we call them alkenes. And if it's a triple bond, we call them alkynes. We'll talk more about alkenes or alkanes, alkenes, and alkynes later. Okay, so here's what we want you guys to be able to do is to draw a hydrocarbon chain that has all single bonds and eight carbons. And the question is, how many hydrogens would you have if you did that? Now, if you do that, you're going to draw, oh man, this looks terrible. You're going to draw eight carbons and then connect them all up. And what you'll notice here is that each carbon is going to have four bonds coming off of it. So that means that every carbon gets a hydrogen above it and a hydrogen below it. And then your two end carbons are also going to have a hydrogen to one side and a hydrogen to the other side. So that means you're going to have a total of 18 hydrogens. Okay, so there's three variety of hydrocarbons. The first one is called alkanes. Those are all single bonds. And what's going to happen here is your alkane is always going to have 2C plus 2 hydrogens. So what that means is, let's say you have four carbons. Your number of hydrogens is going to be 4 times 2 plus 2. So you're going to end up with 2 times 4 is 8 plus 2. You're going to end up with 10 hydrogens. Just because the 2C or 2 times 4 here, in this case, is coming from the fact that every carbon is going to have a hydrogen above it and below it. The plus 2 comes from the fact that on the end of each outer carbon, there's going to be a hydrogen over here, and there's going to be a hydrogen over here. With alkenes are when you have a double bond. They always have twice the number of hydrogens as carbons. So in this case, if you have four carbons, you're going to have 8 for your hydrogens. Lastly, we have these things called alkynes. They always have 2 less hydrogens than the number of carbons. So if you have 4 carbons, in this case, you're going to have 6 hydrogens. So carbon times 2 would be 8, minus 2 would be 6. Okay, what I want you guys to do now is go ahead and practice that. So here is the first one, here's the second one, here's the third one. You should have taken some time to do this. Sorry. Okay, here's what I want you to notice. Notice that with the 4 carbons here, we've got our 10. We've got 2 coming off of each carbon, and then we've got 2 on either side. With a double bond here, notice how this carbon and this carbon have 4 bonds. They've got the double bond is 2, 1 to a hydrogen, and 1 to the other carbon. That's 4. So they can't have a hydrogen coming off here, because if they did, they'd have a total of 5 bonds. And remember, carbon only can have 4. That's the key. With a triple bond now, carbon's got 3 bonds sharing between itself, so it can only use one other bond to bond to the other carbons. Hopefully that makes sense. Triple bonds, kind of why you end up losing, 4 hydrogens. And that's why we end up with only 6 hydrogens instead of our normal 10 over here. Cool. Remember, carbons must have a total of 4 bonds around it. Double bonds count as 2 and triple bonds count as 3. So 2 terms we want you to know: saturated and unsaturated. Saturated means all single bonds. It means carbons have as many H's around them as possible. Everything is a single bond. Unsaturated means carbons don't have as many H's around it as possible, so they are having a double or triple bond. So saturated is all single bonds, as many hydrogens as possible. It's fully saturated, like a sponge is saturated with water. And then an unsaturated hydrocarbon is kind of like an unsaturated sponge. It might have some water, but it's not filled to the brim with water. Or in this case, it might have some hydrogens, but it's not filled with as many hydrogens as possible. This is an example of a saturated hydrocarbon. Notice every C has 4 bonds coming off of it, all going to hydrogens except for, or as many going to hydrogens as possible, versus over here we've got a double bond, so we're kind of missing 2 hydrogens here, so that would be unsaturated. And then here we're missing, 4 hydrogens because of that triple bond. So again, unsaturated. Lastly, I'd like to end with this. The question is, what's the difference between this first structure here and the second structure? You might say that the triple bond is in different places. Here it's on the second carbon versus over here it's on the 4th and 5th carbon. So here 2nd and 3rd, here 4th and 5th. But keep in mind, these molecules are like in 3 dimensions of space. They're not just on a paper, right? It's like an actual thing that exists. So a molecule could very easily spin around. And when it does that, look how these guys are actually the same here. So what this means then is that in the world of science, sometimes we have to tell people where the triple bond is, but we can't just number everything from left to right. We can't just say, oh, it's on the 2nd hydrocarbon, or we can't just say, oh, it's on the 4th or 5th hydrocarbon, because that realistically means the same. So when we're trying to describe where a double bond is, we end up using a numbering system that kind of looks like this. We number from outside in. So the outermost carbons are both carbon 1. The second outermost are both carbon 2. And then the third innermost are both carbon 3. So we would say that this triple bond happens on carbon 2. It's where the triple bond starts. Same thing over here. Since it starts on the 2nd carbon, we would say that this triple bond starts on carbon 2. So we'll talk more about that tomorrow. We'll also kind of clarify stuff on hydrogens. This has been your introduction to organic chemistry. Hopefully you liked it. Hopefully you had a great time. We'll see you all tomorrow.